Next slide. This lecture slide is about Earth impacts. I show you one very nice example of that is the Meteor Crater, also called Barringer Crater, in northern Arizona, just outside of Winslow. The closest major city is Flagstaff. It was formed by a large iron-nickel asteroid 45 meters across. Something that large is going to be called an asteroid, not a meteorite. The asteroid smashed into the plains of northern Arizona about 50,000 years ago. The explosion of the asteroid from the impact carved out this bowl-shaped impact crater. If you select the image, it'll take you to a view from the rim. This impact crater is so large that if it were like a stadium and you had the sides of the crater wall being the grandstands, you could have 2 million people sit in them, and you could play 20 football games or soccer games there in the floor of the crater. Back on the lecture slide, to the right of the picture of Meteor Crater is an image of the Chickzylub Crater derived from local gravity and magnetic field variations. This is the one that formed about 65 million years ago that we think is responsible for finally ending the age of the dinosaurs. Below that is a map of the impact craters on Earth. I think maybe 6 or 7 more have been found since this particular picture was made. It seems like God hates certain parts of the Earth. Of course, I'm joking. This map does ignore any impact craters that would have formed there on the ocean floor. A large asteroid hitting the Earth is not going to be cushioned by the water, so you would form a crater there in the ocean floor as well. The reason why you find more impact craters on some parts of the land part of Earth than other parts is because, number one, some of the places on the Earth are much more explored in more detail than other parts. Number two, some parts of the Earth are much geologically older. The surfaces have been exposed for a much longer time, so therefore we're going to find more impact craters. And number three, some parts of the Earth have more erosion going on or other geologic activity that will erase any of the craters that might have formed. So that's why you'll find more dots, more impact craters, in some parts of the Earth than other ones. The Astronomy Notes textbook goes into the details of what would happen if an asteroid 1 kilometer or larger were to hit Earth. Objects this size would affect the entire surface of the Earth. The textbook also describes how we're looking for all the dangerous near-Earth objects and how we can deflect them so they don't hit the Earth. The key idea to deflecting asteroids is the farther out we can detect an asteroid that is going to hit the Earth, the smaller is the required nudge needed to deflect the asteroid. As far as we know right now, there are no asteroids larger than 140 meters across that will hit Earth within the next 100 years. The last paragraph of the asteroid impact section discusses using asteroids for their mineral and volatile resources for use on Earth and space exploration.